stuff in Unit 3 for most of us, even if you've covered trig before in your life a little bit, like in Algebra 2, we're going much deeper. So you want to really pay attention, take good notes, ask good questions, take your homework seriously. If you're absent, you watch the video when you can, of course. But just know that we keep going in this class, all right? So if you're not here in body or mind, you're missing something, okay? And I want to remind you, well, just like yesterday, I have a lot to say. I'm trying to go a little slower with these notes to really make sure you guys get them, give you opportunities to ask questions if I'm not clear on something. So notes are taking a little bit longer right now, but I want to remind you that I'm building in these work days for you. Like Monday is a work day, and you will have no new assignment. There's not even going to be a homework check that day because I'm not going to be here. You'll use Monday to finish any of these Unit 3 homeworks from yesterday, today, or tomorrow that you didn't. I opened more daily videos, not as a grade, but just as a resource. So those might be good to start looking at to help you understand what I'm going to be teaching you. Just doing anything you need to this class. So Monday is a work day. And again, I don't take many days off. This is like my second or third day the whole year I've taken off. So you guys are a really good class about working together. You kind of get a feel for who understands this stuff and who doesn't. So if you have questions, maybe find a friend that you know is doing okay in here, maybe who's near you or whatever, to ask for help if you need it or whatever. But of course, all my videos and notes and homework cues will be on Canvas, okay? So I want to start with number 15 from your homework yesterday to introduce today's lesson. So number 15, whether you got to it or not, it was a periodic function where you had to label a whole bunch of different characteristics of the graph. Old things we've talked about before in many, 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 many situations. Mins and maxes, intervals of concavity, concave up, concave down. Points of inflection are where the graph changes from concave up to concave down. And you can see I labeled it over here. All my maximums are A, my minimums are B. Concave up is labeled with pink, yellow is concave down, and my points of inflection I labeled with the letter C. So you can look at this and kind of see all the different parts, color-coded, labeled, whatever. What I want you to take away from this graph, though, guys, is that each of these characteristics, A, B, C, the yellow and the pink highlighting, they're all exactly the same distance apart from their neighbor in either direction. In other words, we have a max at 2, right? Our maximum is 2. We have one at -5, 2. We have one at whatever this is. I can't tell. But they're always going to be the same distance. And that's what this lesson that we're about to talk about is really the key about it, is that all my maximums are exactly the same distance apart. All my minimums, this point that begins my concave down matches up with this point that starts the concave down. They're going to be exactly the same distance apart. That's what's really nice about periodic functions. They're very predictable, okay? So that's what I want to start with. So let's start by, and there's this little formula that I'm going to go over. I have to do it with the picture, so just hold on what it says up there. Let's start by something we learned yesterday, then that is to find the period of the graph. So we see just a partial periodic function. It's telling us it's periodic, so we know this is just going to keep repeating. Remember, the way you find the period is by finding a starting point. You all can pick a different point. It doesn't matter. Pick any point you want and start there. For example, if I start here, what I want to do to find my period is travel along this graph. I'm starting at a max, right? I just happen to choose the max point on this graph. So to complete a period, I need to hit all the points down to my minimum and go back to where I started. Periods always start and end at exactly the same y value, okay? So that's a period. I could have gone from here to here. That would have been a period, starting at a minimum, hitting the max, going down. It doesn't matter, okay? So that makes no difference. Now, what is the period of this graph? Well, I'm going to use pencils so I don't mess up the whole graph. But we want from what, so remember, period is what chunk of the x-axis do we use to draw that period. So this is the value for this point, right, -2, and +2 is the x value of this point. And I drew it like that so you could really see. This is the section of the x-axis that we use to make this period. So what would the period be? 4. The period will never be what? What am I going to say there? Negative. Good. Period is a distance, okay? Whether we go forward or backwards, it's a distance. How many pieces, how many intervals of the x-axis do we use? That's always going to be a positive number. Period is 4. And that's a non-negotiable. Even though you could outline any different amount of cycles, like I started here or here, it's always going to be 4, okay? Period. Now, let's complete the behavior. I want to keep going with this graph for the rest of this coordinate plane. Use the fact that I just told you a minute ago to help you do that. I have maximums here, here, and here. How far apart are they? 1, 2, 3, 4. 1, 2, 3, 4. So I'll have another one, 1, 2, 3, 4 away. And then I would be off the graph, so I'll go ahead and stop there. Same with my minimums. My minimums are 4 apart. So if I start here, I can find my next one by going 1, 2, 3, 4. 1, 2, 3, 4. And that's just an easy, quick way to keep graphing. Because the characteristics, maxes, mins, repeat over and over and over again, exactly the same distance apart. Makes it nice and easy to graph, okay? So we did that. Now for this formula. What I was just doing by counting 1, 2, 3, 4, 1, 2, 3, 4 is what this formula is saying. It's saying that for any characteristic that we want to talk about, in this case it's asking about a minimum, we can plug some numbers in this little formula to predict where the next one is, where the next one is, where the next one is, where the ones are that are 10 miles down the road or 10 miles down the road in that direction. Because, by the way, this graph goes on forever and ever. We're just seeing a little screenshot of it, okay? So what that means is this. Pick one of your minimums. It doesn't matter which one. So when you are going to do this, you're going to have choices. And you could pick something different from your neighbor, and you're both right, okay? So we have a minimum here, 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 or here. Pick any one. It doesn't matter. So let's just say this one. We have a minimum at -5, -2, right? There's a minimum, and I'm picking minimum because it said that in the direction. So that's going to be my x value of this little formula. So x that I chose was -5. You could have used -1 or 3 or 7 or whatever, 11, whatever that is, okay? So any value, but this is what I chose, that's why my x is -5. N is these numbers, positive or negative. N is like how many times you move from that point. So if I'm talking about n equals 1, +1, that's right here. If I'm talking about 2, that's from here to here, that's 2 away. From here to here would be n is 3, n is 4, n is 5, n is 5 trillion. Or we could go in reverse. If I wanted to find where this point is that direction, I would just make n be -1. So if I'm going backwards on the graph, I'm going to use negative numbers. Forward towards infinity would be positive numbers. That's what n is. The last number in this formula is k. K is the distance apart that this characteristic is. For us, these minimums are 4 apart, right? Every 4 units, we hit another minimum. So let's not do a whole bunch. Let's do 1 and 2. Let's prove that this formula gets us these 2 points, because this would be n is 1, this would be n is 2. So for example, I could type in f of -5 plus n is 1, and use any number you want, but we're going to do 1, and k would be 4. So -5 plus 4 is -1. That's telling me that our next minimum is going to be at x is -1. And it is, right? It's right here. There's my next minimum. That's where n is 1. Let's do n is 2. What should I get when I plug a 2 into that formula? What should my answer be? 3, right? No, you said 3. Okay. Yeah, because that's my next one. That's where n is 2. We're just showing that this formula works, and we'll apply it a different way in a second. So if I put a 2 in for n, always times 4, that's going to get me to 2 n's away from this. which would be this one. Here's 1n, here's 2n, and so on. So this would be negative 5 plus 8, which is 3. So we get f of 3, x is 3. Yep, that's what we got. So this little formula helps predict future and past on the graph points, okay? And we'll do another one in a minute, okay? Question before we go on to example 9. Example 9? Okay, stay with me. So example 9. What this sentence right here says is really kind of what I'm getting at. It's here in writing. With periodic functions, all characteristics found in one period of the function will be in every period. And again, characteristics are all those little pieces that we've pulled out of so many graphs, mins and maxes and concavity and points of inflection, rates of change, intervals of increase, decrease, all those things that we're going to start seeing again from Unit 1. That you'll see a lot on your AP exam. I'll do a lot of our review, but I don't want to get ahead of myself. Let's look at example 9. So here is a periodic function, right? It's just repeating up, down, up, down. Let's find some important stuff. The period. Pick the place to start. How about here? You pick wherever you want. If I start here, I'm starting at a middle, in the middle of it, and I would have to hit the top, make sure I hit the bottom, the min, and you always end where you start. That's how I know where to stop, because it's always got to be the same exact y value. Okay, so from 0 to 8 is a period of 8. There's my period. That's going to repeat every 8 units. The amplitude we learned how to do yesterday by using our midline first, and you might start being able to see your midline on a lot of these without having to do the formula. Remember, the midline is your max plus your min divided by 2. Well, remember, when your max and your min are the same value but different signs, 0 is right in the middle. So I don't need a formula to tell me that 0 is my midline or to be able to easily find my amplitude. Again, remember what amplitude is? It's the distance from your midline to either your max or your min. These are the same distance. Doesn't matter which one you look at. Amplitude's always positive because it's distance, and that would be 3, right? From 0 to 3 or 0 to negative 3 is a distance of 3. Okay, now, if you're zoning out, please listen. The word interval. Here's a word we haven't seen in a while. It is such an important word, and it's such a common mistake for students to forget or apply it wrong, okay? So I'm going to take the second to write what an interval is. Interval is always the x-axis. So whenever you're asked for the interval of something, concavity, increase, whatever it may be, what that is saying in Tracy Morse language is what chunk of the x-axis does that happen on, okay? Interval means x-axis only. So where is my graph concave up? Well, there's a little piece, there's up, there's up, right? So I can look at this graph and easily tell you where I have full intervals of concavity. That's like a partial one. So if I was going to just name that on this graph, where does my graph have intervals of concave up? I would say from -4 to 0, right? That's the x-axis. And this is where we had lots of deep discussions back in August, September of do you use parentheses or brackets? Either one is fine. So you can use brackets or parentheses for concavity. Wait, I'm questioning myself. Concavity is the one. Now I have to look at it. I think concavity we have to use parentheses. I'll double check that. I'm going to use parentheses. And we have another one from 4 to 8, right? So that is an x value to an x value, an x value to an x value. Those are not ordered pairs. They look like ordered pairs. They're not ordered pairs. We're just saying from -4 to 0, we're concave up. Also, we are concave up from 4 to 8. That's what that's saying. But I want you to tell me where we're concave up on the entire graph, which goes on for eternity in that direction and negative infinity in that direction. So how do we do that? Well, we're going to use that little formula. So what I'm going to do is say, okay, pick either one of these. It doesn't matter which one. Remember just a minute ago, Daniel, I was saying pick any minimum you want. Doesn't matter. I happen to choose that one. Same idea. I have two different ones. You can use either one. Makes no difference. Okay? I'm just going to use this one. And what I want to do is take a second and look at my graph. How far away is the point that matches this point in the next period? So here is my beginning of my concave up. What's the x value where that starts again, that matches up with this point exactly? What's the x value? No. 4. See how this starts the concavity? This is concave up. Okay, so we're doing concave up. Okay, so how far apart are those? When does this point happen again? 8 units away, right? From -4 to 0 is 4. 0 to 4 is another 4. That's 8. Guess what? That means K is 8. Every 8 units, we're going to have this exact point happen, okay? Same with this point. Let me do it in green. This point on 0 matches up, Zach, redeem yourself. Where does this guy's point match up with? What's the x value? Nope, 8. Okay. From 0 to 8 is where that happens again, right? Are you guys seeing this? So you have concave up and it ends right here. Concave up, it ends right here. So 0 and 8, those x values are matching points in the period. So K is 8 is my point. Every time you want to make another one of these, it's 8 apart. So here's how you write it. -4 plus or minus, I'll come back to that, 8n, comma, 0 plus or minus 8n. The plus or the minus really applies to the n because positive n is going to the right, negative n is going to the left, okay? And every 8 units, 8 ends, 8, 1, 2, 3 in either direction, I'm going to hit another point that matches that. That's what that means, okay? So this covers every single interval of concave up on the graph for eternity. Now, here's a new symbol for you. N, E, Z. Let me make that Z a little bigger for you so you can really see it. I don't care if you ever write this. I just want you to know what it means when you see it, and I'm going to tell you what it means. N, let me find a spot. N is, make sure you use all the right words, of any variable. So N is just a variable, okay? And E, so this symbol means belongs to in math, belongs to. And Z is the set of all integers. Sorry, I'm squeezing it. Integers are whole numbers, positive or negative. 1, 2, 3, 4, 5. -1, -2, -3. No decimals, fractions, okay? So what this is saying is this with this covers all the numbers to the right, all the numbers to the left. Because N can be any number you want. You can put any number there. So it covers positive infinity to negative infinity. All right? I just want you to see it. It's not something you're tested on, not something you get points off if you left it off. You'll see it, so it's just my job to introduce it to you. Okay? Let's do intervals of concave down. So think about what we just learned about concave up. Stay with me, stay awake. Concave down, and a little section of concave down. So I have 2 different parts of the graph that are concave down, right? So what are the intervals? Well, from -8 to -4, right? -8 to -4. And it happens again from 0 to what? To 4. So here, pick either one, right? I happened to pick the first one last time. I'll pick this one because it doesn't matter. Because when you put the 8n and the plus and the minus and say it could be any n value, you're hitting all the points, including this one, okay? It covers everybody. So, and again, this point matches up to this point, and this point matches up to, they're 8 away. So K is 8 again. So you just have to see how far apart. When does it repeat that same matching point? And it's 8. So if I'm going to use 0 and 4, that'd be 0 plus or minus 8n, comma 4 plus or minus N, E, Z. That covers every single interval of concave down on this graph from negative infinity to infinity. So just take this away before we do our last part of this problem, we have more to do, is multiple choice test. Or on my key for the homework or something, I might have picked 0, 4. You might have picked -8, -4. We're both right, okay? So just understand there's more than one possible answer that is correct. All right, point. When you hear the word point, that looks like these, but it's literally an x and a y. It's the good old-fashioned point that you have on a coordinate plane that you're used to, okay? So interval is from this x to this x. A point is x, y on the grid, right? Left, right, up, down. So points of inflection, they're already circled. I'll put x's on them. That's where concavity changes. We got a whole bunch of them. Let me read them to you, if I can. -8, 0. -4, 0. 0, 0. 4, 0. 8, 0. And forever, every 4 units apart, left and right. So every 4 units, we're going to hit another point of inflection. Pick one to start with. It doesn't matter which one. It doesn't matter. You've got lots of choices on here. Every single one of them would get you full credit. Pick one. I'm going to pick this one. -8, 0. So I'm using -8, 0. Well, one thing that all of these had in common, what did every single one of these points of inflection have in common? 0. So we're going to put -8, since I chose that one, I chose that as my x value, -8 plus or minus 4, k is 4, n, and I could just put 0, because it's always going to be 0. They all have a y value of 0, from right to left forever. Okay? And technically the NEZ, I'll be leaving that off often. You can leave it off. If you see it, now you know. Just the same, you can use any n value you want. All right, we're only going to do part of example 10 and then a really important word problem that is pretty easy, and then we'll do homework. Stay with me, okay? You know I'm not a busy work kind of girl. You know I don't just go over every single example. I painstakingly look over every example, choose what I think is important. I don't do every single problem or assign every problem. So if I go over something, there's a reason for it. Okay, we're only going to do a couple parts of this. Let's practice finding the period, okay? Thank you. So funky looking graph. These are the ones we're going to start seeing from now on, starting kind of tomorrow and on. We're still talking about any kind of periodic graph, which just means it's repeating like this. So when I look at this, I hope you guys can see it. I kind of see a W, right? A W and then another W. So this would be my starting point of a W, and it would end there. So what part of the x-axis is that? From -5 to 3, 5 to 0 is 5, 0 to 3 is 3, 5 plus 3 is 8. So 8 units of the x-axis, okay? Period. Amplitude, this one's not as easy as the other ones, but hopefully after all the ones we did yesterday, you can do these pretty quickly. Since my max is 4 and my min is -3, max 4, min -3, I'm going to find my midline since they're different. So my midline would be, and you don't have to show the work, remember, max plus min divided by 2. So that would be 1/2. So I have a midline at +1/2. And now it's really easy to find my amplitude, the distance from here to here, or here to here, either one. If I count those units, that would be 3.5. Okay? Intervals of increase and intervals of decrease, very similar to intervals of concave up and concave down. This is the part I'm not going to do the whole thing. I just wanted to remind you what increase and decrease means. Think of slope. Interval of increase is rising left to right, like a positive slope. Decrease is where we're decreasing, like a negative slope. So this is decreasing, right? This is decreasing. This is increasing or increasing. So I did give you these in your homework, and I showed all the work. So if you need help with those, let me know. But it's exactly what we did up here with concave up. Okay? One thing I want to do is one of these problems, and that's the AROC. AROC is a huge part of this class. We've had to find it in so many different graphs, and here we are again. The word interval is given here. When you see that word, we have to remember that these are both x values. So they're saying, what is the slope, right? AROC is just the slope from where x is 2 to where x is 3. That was a bad color to use. This right here, x is 2 to 3. So we know our x values are 2 and 3. We need 2 points to find slope, right? So the two x values are 2 and 3. We can grab the y values right off the graph. Can't really read my graph anymore, but those are the 2 points. That's what it's saying. And we know the slope formula. Change in y's over change in x's. Y's on top, x is on bottom. So that's 4 minus negative 3 over 3 minus 2. 4 minus negative 3 is 7. 3 minus 2 is 1. The AROC slope rate of change is 7 on that interval of the graph. Makes sense that it's positive because it's increasing, right? Okay. So I just want to remind you of that. You don't need to find a whole bunch of slopes. Mm-hmm. Mm-hmm. Are you good with it? Okay. Yep, because they're so long already. All right, example 12. Super important question. So get to example 12. It's not hard, but this is where I'm going to really start introducing to you what you're going to see on FRQ 3 and on the test. And we're going to do lots of word problems. You're going to start getting to the point where, like, they get easier and easier the more you see them, okay? And then when I throw something that's a little bit harder in it, it's going to make it so much easier because you understood the easy ones, okay? So just stay with me, trust me, please don't tune me out. A Ferris wheel. I told you yesterday, all these word problems, they love Ferris wheels, clocks, and wheels. Lots of circular things that move. A Ferris wheel at the Orlando Eye attraction is 120 meters in diameter. That's probably important. I'm going to underline it. The height in meters of a compartment H is a function of time, t, and minutes. So H of t, okay. It takes about 30 minutes to make one complete revolution. So you start, goes all the way around, you end back up at the bottom. When you got on, it takes 30 minutes. But the height of the car when you enter the ride represents the height at time 0. So when you get in the car, we'll call that 0. Here's my Ferris wheel. Gorgeous. And what we're going to do is make up some ordered pairs that represent this on this circle, okay? So it told us a couple different things. Oh, wait, let me back up. In a minute, we're going to have to graph it, and it told us in here that the x-axis is your time, right? Time is almost always your x-axis. And this time, it's time in minutes. And our y-axis is almost always height, and it's different measurements. This would be meters. Okay, so we're going to come up with some ordered pairs. X will be your time, Y will be your height. And let's start at the bottom. So this is where we're getting on the Ferris wheel, okay? And it said time is 0. So, oh, sorry. Yep. So I just put time, minutes, height, meters. To identify that as I do these ordered pairs, the first number is going to be time. And it's at time 0. And let's just call this at 0. Let's just say the bottom of it is at a height of 0. Okay? Now, you can either go clockwise or counterclockwise. That doesn't make a difference. So just for the sake of making a decision, I'm going this way. So let's go halfway. So up at the very top, when I'm at the top of the Ferris wheel, how much time has gone by if the whole thing, let's add this right now, if the whole thing takes 30 minutes. So if I start 0 time at 0 height, I go all the way around, I end up back here after 30 minutes, same height, right? Same at 0. So what would halfway's time be? 15. And remember that 120 meters in diameter? Diameter is the length from one endpoint to the other in a circle. So that would be 120 if we're calling that 0, right? From 0 to 120. All right, let's put in 2 more. Let's break up our 15 minutes into 2 more times in heights. So I start at 0 and I end up at the top at 15. What I want here for my time is halfway between 0 and 15. That's like midline. Add your 0 plus your 15, divide by 2. That would be, in my calculator I got this, 7.5. Let's do time over here. So 0, 7.5 minutes later I'm there. 7.5 minutes later I'm at 15. Well, this is going to be 17.5 minutes later, or the halfway between 15 and 30. 15 plus 30 divided by 2 is, in my calculator I found this, 22.5. So I've got all my times, and then of course 7.5 minutes later I'm back to the ground. That's 30 minutes later. So I broke this circle into fourths. Each of them are 7.5 minutes apart. What would the height be for these 2 points? 60, Jaden. Jaden, good job. Right? So halfway, 0, 60, 120. What we just did pretty simply is come up with 1, 2, 3, 4, 5 points that now we can graph pretty simply. Okay? And then we'll find the amplitude. So let's just graph these. It doesn't have to be perfect. 0, 0, we're on the ground. Then at 7.5 minutes, we're at a height of 60. Then we're at our maximum 15 minutes later at 120. We're at the top of the Ferris wheel. Then we start coming down. 22.5 minutes, we're at 60 again. And then on the ground, 30 minutes later. And connect it with a curvy graph, and there is a graph of that motion. Anybody want to take a guess at what, not a guess, educated guess at what the amplitude is? Not 120, 60. So if you found the midline between 0 and 120, that would be at 60, right? That's the middle between 0 and 120. The amplitude would be the distance from here to here or here to here. So from 60 to 120 or from 0 to 60 would be 60 meters. We already sketched the graph. Last question. At what time does the Ferris wheel reach its maximum? What's the answer? 15 minutes. Right? 15 minutes maximum. 15 minutes maximum. Okay? All right. Homework. Page 10. I would go ahead and cross out part D and E on 3 and 5 so you don't do them. Come on, give you time to work. I'm here to help. Okay. So I have all 4 of them up here for you. 1, 3, 5, 6. Yeah. Yeah. Guys, number 1's points are annoying. They're annoying. There's decimals. Don't spend an hour on this graph. It does not need to be perfect, okay? So you have time is months, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 months. And then those temperatures, just don't spend tons of time breaking those little decimals up, okay? A very rough graph is totally fine. Okay, I'm going to pass this stuff up. If you didn't write it down, number 3, omit part D. Number 5, omit part E. So, principles. I should know that, shouldn't I? Okay, I'm going to look it up. Does anybody off the top of their head know the difference between honor roll and principals list? Did you hear that, Daniel? Okay, yeah, they don't go by percentages. It's more number of A's, B's.